Question 4. Cool Tees is having a back-to-school sale where all t-shirts are discounted by 25%. He wants to buy 5 shirts. One originally cost $8.99, 2 originally cost $10.99 each, and 2 others originally cost $24 each. What is the total cost prior to the discount, or prior to tax, of all of the shirts including the discount? All right, so the first thing I'm going to do is I'm going to add up what all of these shirts would be total altogether. So we have an $8.99, we have 2 $10.99s, and we have 2 that are $24. So when I add all that up in my calculator, I get $78.97. But we also need to add in the discount. So if I take my original amount, and we talk about the discount now, discounted by 25%. So if it's discounted, it's going down. So again, anytime we go up or down, we start at 100. So if we go down 25, we would be paying 75% of that. So change that percent to a decimal, and we get $59.23. Question 5. By law, sales tax is calculated on the discounted price of the shirts. Would the total cost of the shirts, including the 7.5% sales tax, be greater if the tax was applied before the 25% discount is taken rather than after a 25% discount is taken? Explain. Okay, so if we're looking at before, so we had a total of $78.97 for our shirts. And we could take that times our tax rate. Now remember, tax is adding to the price. So we're going to start at 100%, and we're going to add that to our 100. So it'd be 107.5%, which if we make it as a decimal would be 1.075. And if we multiply that, that would give us a total amount of $85.09. But then we need to add on our discount. So if we go $85.09, that's our amount, times our discount, which was 25% off. And like we talked earlier, that would be 75%. If I write that as a decimal, 0.75. And when I multiply, I would get $63.82. Now let's look at what it would look like if we did it after. Okay, so we know that our total from our previous question did the discount, was $59.23, and then we want to add on our tax. So we're going to do the 107.5% of that, so 1.075, and when we multiply, you get 63.82. So in this case, it doesn't matter. And it doesn't matter because all we're doing is multiplying. And when we talk about multiplication, multiplication has commutative property, so we could flip-flop these orders and it not make a difference in what our final answer is. So we're going to say multiplication is commutative, C-O-M-M is commutative. Okay, let's look at number 6. It says Joshua remembered he had a coupon in his pocket that would take an additional 30% off the price of the shirts. Calculate the new total cost of the shirts, including the sales tax. So we're going to use our total from the question before, after we did the tax and the 25% off. So we had a total of $63.82. And then if it's 30% off, remember we start at 100, so we would times that by 70%, which would be 0.7. When we multiply in our calculator, we would get $44.67. Okay, let's look at number 7. Papers want to stick together here. Okay. Number 7, if the price of each shirt is 140% of the wholesale price, write an equation to find the wholesale price for a $24 shirt. So let's think percent and whole. We know our percent is 140%. If the price that the customer is paying is 24, that's the part we pay, and we want to find the wholesale price. So that's the thing we don't know. So your equation could be 24 equals, you could write it as 140% times your wholesale price, or you go ahead and change this to a decimal as well, make that 1.4W.